Good evening, friends. Today I will tell you something about the centripetal force in circular motion. This idea of force is very interesting and it has various applications in our daily lives. The first thing that I want to tell you is whenever a particle is performing a circular motion, it is always performing the circular motion about the center. This is the fixed center, and here the particle is moving along the circle. The other thing that we always associate a radius vector with the particle, which is directed from center towards the particle. As the particle moves, the radius vector also moves. What is necessary is that we know in a circular motion, the linear velocity of the particle always changes its direction. As you can see, suppose the particle is here, the linear velocity is directed along this tangent. Suppose if the particle comes here, the linear velocity is directed here. If suppose the particle comes here, the linear velocity goes here. So as the particle changes its position, the direction of linear velocity also changes. Due to the change in the linear velocity, there is an acceleration which the particle experiences, and that acceleration, if I look carefully, if I draw this, is like this way. That acceleration acts towards the center of the particle. That acceleration is known as centripetal acceleration, whose formula is given by v square upon r. So basically, whenever the particle moves on the circle, the direction of linear velocity changes, due to which the particle is accelerated towards the center and along the radius, Since there is an acceleration, since we have an acceleration, then we must have a force which is also directed towards the center, which is simply by Newton's second law, mass multiplied times acceleration. So in our case, mass multiplied by the centripetal acceleration. This force is known as centripetal force, which is necessary to maintain the circular motion of the particle. If there is no centripetal force, the circular motion is not possible. So it is the necessary force required to maintain the circular motion. We can take an example. Suppose you have a string, you tie it to a stone and you revolve the string around some fixed point, around your finger. You hold the thread on this end and you revolve this string. The necessary centripetal force is provided by the tension, the force of tension along the string. When this tension becomes zero, suppose if we cut off the string, where will the stone go? It will go along the tangent. It will fly along the tangent. So here, the role of centripetal force is provided by tension. If we look at the universe or solar system, sun is the center, earth is performing the circular motion around the sun. The centripetal force is provided by the gravitational force between the sun and the earth. If we go to an atomic scale, then electrostatic force of attraction plays the role of centripetal force between the nucleus and the electron. So there are numerous examples of centripetal force. If suppose there is a curved road and if the vehicle is traveling, the force of that we known as the force of friction It acts as a centripetal force, which is given by mu times the normal. Thank you very much. So this was an idea of centripetal force.